All right, welcome everyone. So today we are doing notes and examples for 6.6. And yes, you want to write this down. Geometric sequences. Okay, geometric sequences. And that sounds like a mouthful, but it's really not bad, and it's something that you've all dealt with already. You just kind of don't realize it. So first off, I'm going to back up a little bit. Let me do a quick table. Shorten this up a little bit. Move this over. And let's take something that we're really comfortable with. This is our security blanket of numbers, X and Y, and 0, 1, 2, 3, and 11, 7, 3, -1, something like that. What kind of a function is this? What kind of a function? We've done a lot of these. Tianu, what did you do each time? Yeah, I went -4, -4, -4, and it would continue on and on. Exactly. And so we say this is a linear function or linear equation can represent it. I'm going to remove that over just a smidge. This is a linear function because -4 is a common difference. Okay? And when we were doing graphs, what would that be known as? What would that be known as, JJ? If we were graphing it? Kathy, what would it be known as if you were graphing this? No, the -4 part of it. Yeah, slope. Good. Okay, let's try to stay with it then. Okay. Okay, now, if we were then to incorporate that slope, we would say y equals -4. Brandon, what's the next part? -4x. Good. Y equals -4x. And then what's the last part, Damien? Y equals -4x. Then what? There's one little bit plus something, not 1. Plus 11. There it is. Thank you, Daniel. Because 11 is the starting value, as someone said. What was mean? Okay, so you look at the 0 term for x and you say, okay, that's the y-intercept or the initial condition or the starting value. Very, very important. And so the slope is -4, y equals -4x plus 11. Okay? Absolutely right. Now, here's the new part. Here's the new part that we're going to get to today. If you just take this bottom row of the table is 11, 7, 3, -1, comma, Talia, what would the next one be? What would the next term be? Like -5, yeah. And it would keep going and going and going. Okay, I'm going to say this set of numbers is called, here comes new term, maybe, maybe not, and I want to show that, and arithmetic sequence. this set of numbers, okay, S-E-T. And it's no big deal. You're just taking the bottom row here. You're just taking the bottom row here and writing it out in order. No big deal. And they have a common difference. And I'm going to put that in parentheses here. Common difference. Okay, now we're going to get to the good part. The last couple weeks with Ms. Boatwright, you've been working with something a little bit different, okay? You've been working with tables that look like this. Bring that down. Going to scoot that over. Okay, Keanu, are you writing all these notes down heavily? Yes. Now, how about all of them? X and Y. 1, 2, yeah, 3, 4, 5. And then let's go, I don't know, 3, 12, 48. Now I have to do my homework. Uh, 192. Yeah, gosh, it's so late in the afternoon I can't think. 192. And then 200, and then 16 would be 784. I hope that's right. Wait. 960? It's 700 and... Check me on that, Daniel. Give me 960. What's 192 times 4? I gave it away. 768? Are you sure? I believe you. All right, here we go. So, Damien, help me out. Natalia, how are you? Good. So, this one, if we try to take the difference here, the difference between 3 and 12 is 9. The difference between 12 and... Not yet. We're going to get there. You're jumping ahead, Kathy. We're going to get there. If we try to take the difference between 12 and 48, we get 36, and we go, oops, this one is not linear, is it? No, it's not, because 9 and 36 are not the same number. Oh. They're not the same number, so we know it's not linear. We know it's not arithmetic, and so we say this is something else, okay? And so we say, okay, and as Kathy pointed out, you can't add, you have to multiply. Kari, what could we multiply each time? What could we multiply each time to get the same result, same product? Yeah, by 4. Very good. So we can go times 4, and then 12 times 4 is 48. 48 times 4 hopefully is 192. And so we are going times 4 each time. Okay? Exactly. And we say that this is an, what is this kind of a function called? Now, you can tell me, Naomi. Yeah, say it. You're not sorry. Exponential. Never apologize. Exponential function. Because the common, now we don't have a common difference. What's common? Common, what's that called? You're right. Times 4, the common starts with an R. Ratio, there you go. You're on fire today. Yeah. Okay, the common ratio is times 4. I should put is. I left that off. The common ratio is times 4. That's major. And if we wanted to write an equation for this, we could say what? Y equals, remember they were a, b to the x. Remember what they were? Yeah. What part goes where? In stereo. Well, in this case, you'd have to be a little bit. You'd have to adjust it a little bit. You'd have to say 3 times 4 to the x minus 1 term. What? Well, because 3 is the starting value, right? This one you could adjust just a little bit and say 3 times 4 to the x minus 1, because you really kind of can treat this as a 0 term, and then it would work. The main point here is that this is exponential. And just as we had arithmetic that went with linear, we have something that goes with exponential. Okay? And here we go. What color did I use here? I want to be consistent. Bottom row, purple.
I already did that part.
Okay. The bottom row, which is 3, 12, 48, 192, and 768, is a, give me purple again, is a geometric sequence. And it keeps going. Is a geometric sequence with a common ratio of 4, because we multiply by 4 every day. It's not so bad. It's just a little different way to look at those functions that we did in tables. I'm going to have you guys do a couple of examples. Let me see. Or maybe I'll do an example and I'll record that and then I'll stop for you to do some. Okay, how far are we into this? Not all of them. We're 13 minutes in, so I want to go for like 2 more minutes. So what if I gave you as a example, really fast, what if I gave you 2, 10, 50, 250, ... Okay, who haven't I picked on yet? Zach, how are you? What is the common ratio? Common ratio is 5. Guys, girls, it's starting to get a little buzzy in here. I'm almost done. I promise to not go for too much longer. Okay? The common ratio is 5 because you go 2 times 5, you get 10. 10 times 5, you get 50. Okay? Notice that 5 is greater than 0. Okay? And I'm going to show you one that's less than 0 now. Okay. That'll be number 1. And this will be number 2. Okay, how about this? What if we go 81, 27, 9, 3, 1, 1/3, eek, and it keeps going. Okay? Think about that for just a moment. What is the common ratio on that one? Keanu? So if I multiply 81 times 3, do I get 27? Oh, okay. So dividing by 3 is the same, and you're all right. Dividing by 3 is the same as multiplying by what? Careful. Luis? 1/3. So we're going times 1/3 each time. So the common ratio is 1/3. Now, notice that 1/3 is less than 0. And notice what happens to this sequence versus 5, which is greater than 0. Notice what happens to this sequence. Boom. You are so right. Okay? So that's what's going to happen. And they're going to ask you about that. They're going to ask you about that in today's homework. Last one that's really weird. This is the crazy weird one. This one is bizarro, man. Yeah, this one is crazy weird. So what's going to be, I know you know, Kiana, wait just a minute. Brenda, what do you think would be the common ratio there? Well, come out with your best guess, Brenda. Okay, what are we doing to go from 4 to 8? Forget about the sign. Forget about the sign for now. What are we doing to go from 4 to 8? Times what? Yeah, by 2. So we're going times 2. Now, how can we change that to make it go from 4 to -8? Yeah, yeah, times -2. So, hey, time out though. Does it work again if you go? Remember, it has to work every time. What about 8 times -2? Abel, what does that give me? 8 times -8 times -2. Positive 16, and then it keeps going. And so well, sometimes you have to use parentheses, so be careful. And sometimes those phone calculators really are stupid. But anyway, if you see the sign alternating, negative, positive, positive, negative like that, just know that your common ratio is negative. Oh, you know what? I just noticed I made a mistake up here, you guys, and I apologize for those of you that are doing it in pen. I know! Well, don't do it in pen. This should be less than 1 up here, and that is so smart. And this should be greater than 1. That was my bad. This one here, 5 should be greater than 1, and 1/3 should be less than 1. And then these guys here can be less than 0. Okay. R is negative. Okay. So I am going to shut down now. Awesome job. Recording. How much did we do? 18 and a half minutes. Not too bad.